Okay, now we're going to analyze graphs of quadratic functions and get comfortable with writing the equation of the function. So notice this first graph right here. It just looks like a standard polynomial. And remember to write this parent graph, you would either write y is equal to or f of x is equal to. And here's one way you could do it. You could pick a point. So let's pick one right here. And we know that a quadratic is a second degree, right? So if you type in 1 squared is 1. Well, are we up here at 1? We are. So if that's the case, this is just the parent graph. So you could write y is equal to x squared, or or f of x is equal to x squared. All right, so notice for this one, now it has been moved or shifted is the correct phrase, but this is what you want to check. Is the slope any different, or is it still the same slope as the parent graph? So here we are at 0, here we are at 1. So if we come to right here, here's this point. When we come over here, well, we went over 1, we went up 1. So if we put in a 1, 1 squared is 1. And so we know that its slope, there's going to be y is equal to x squared or f of x is equal to x squared. But what has happened here? It went from here, it got shifted up to. So for this equation, because remember when you go up and down, the number goes on the outside of the equation without the parentheses. And then when you're shifting left and right, that's when if you were to shift right, the opposite of that. So let's say I'll discuss that in just a second when we actually have one like that. All right. So if it's the normal parent function, you just write it in the standard way, or the normal way you'd see a function. If it has been shifted up, on the outside of parentheses, you add or subtract depending on if it got shifted up or shifted down. And look what's happened here. So if we come over to 1 squared, so this is not the parent graph. So, and it started, so if we put in 0, so if we put 0 squared, we're here at 0. So we know that it hasn't been shifted left or right or moved up or down. So what that leaves us is what's happening to the slope. So when we put 1 in here, an x value, well, what do we do to 1 to get it equal to 3 without adding? Because everything would be added. That is when it is a stretch or the slope has been changed. So in this case, 3x squared. Now let's look over here. So I'm going to look here again. If we went over 1, up 1 over, okay. So if that started at the origin, that started right here, if this vertex point was right there, that next value just, when you move the x over 1, 1 squared is 1. So we know that the slope is the same as the original parent function. But what has happened? Well, let's see. The vertex, it got shifted to the left 2, and it got shifted down 3. So when stuff gets moved up or down on the outside, so we're going to put subtract 3. The inside part is tricky. We move to the left 2, but on the inside, we need to do the opposite. So we're going to say plus 2. And that is how you write these quadratic functions. So when you're analyzing functions, one of the things that you could do is write what the new function equation would be. All right, that's it for this one.